Today we will discuss the implementation of stack using linked list. Okay. While discussing the implementation of stack using static memory allocation in array, we discussed that there was constraint. Two constraints were there. Uh, Whether the stack is only one constant, not two constants. If the array is completely filled up, with which we are implementing stack concept, stack ADT. The array is completely filled up, then we will not be able to push any more item in the stack. That's why over there we had to keep a constant, a condition before we push any element on the stack. Our program was supposed to check whether the stack is full or not, isn't it? Could you recall?
Yes, sir. A condition is needed.
Exactly. But here that condition is not valid, right? Because here we will be allocating the memory dynamically in dynamic memory allocation using limits, right? So there is no chance to get the memory full. A dire consequence, theoretically, you can say that if your RAM gets completely filled up, so that is a very rare case, yeah, because you know nowadays we have huge amount of memory RAM at our disposal. So very rare chance to get the complete system memory filled up, right? So that we will discard. That is an ideal situation. So here generally that uh, the uh, stack full condition will not occur. So we don't have to bother about. Okay, let me open. Let me start presentation. Just, share. Let me start that material, okay, that we discussed with uh, while discussing while we discuss the stack, okay, using array. Here you know that is just for your uh, revision. This is the last in first out the stack. All of you know the mainly these two operations we will be implementing, push and pop operation, right? So is empty or is full is empty may be a case, right? But is full condition is not valid here, and peak definitely you get the top element. So this we will be implementing the code. So the conceptually our diagram will be this. Okay. So you can see this is a linked list, isn't it? Each and every these are nodes, the data part, and this is the link part. The same data structure of the single linked list we will be using here. When there was no element present on the stack, so the top will be null, right? Let's say when the first element here 25, this node containing 25 will be inserted, this will be our topmost element, only one element. When the second element will be pushed, so this will be our top element, right? After we insert the third element, this will be our top element. And after we insert the fourth element, this will be our top element. Okay. This way, always top, this pointer will keep on changing. Got it? Hello. The screen is
Yes.
visible. Screen is visible though.
Yes, sir.
So that the element we will insert at last will be our topmost element. This you can consider as a head or root of our linked list. Now we will change the name. We will replace the name of root by top. Right. So we can see what function from linked list manipulation resembles with this push function. Could you say what function matches with this push function? What will implement? What I said, right? Resembles or match with this push function. You can see a create function of linked list. What a create function does? Create function adds a node at the end, isn't it? Hello, hello. Am I correct?
Yes, sir.
I'm correct. Think properly. Hmm? Am I correct? What I told? That push function. I just told you always we are supposed to change the top pointer. Top you can consider as an head or root of the linked list. We are adding a node and we are changing the top. We are changing the head. So which function of linked list matches with this push function? I told wrong actually. Sometimes what I do intentionally, I do something wrong. I say something wrong to test whether you people are concentrating or you people are thinking properly. It is not add at end. The create function at all resembles with this push function. In create function, what we do, we add an element at the end, isn't it? But here, what we are doing, we are changing the root or top. Means we are adding the node at beginning. So the push function resembles with the add at beginning function of the linked list, not the create function where we are adding the nodes at the end, isn't it? What I told you that if you draw the diagram horizontally, it is a vertical diagram, na? You draw the diagram horizontally. First 25 will be inserted first. Then we have to insert 32. So the root will be changed when the only one element is there in the stack. 25 was there. This will our this will be our root node or the topmost element, right? Only one element in the stack. When we will insert this one, this node will come before the 25, right? Conceptually, it will be placed at the top. So this will be our first node, root node or top node. Then 50 when we insert this one, this will be our top node when we insert continue. This will be our top node. So always we are adding a node before the first node. Got it? Hello.
Okay, sir.
Hmm. So let me implement this, program. So the same, see here, I think I have opened that program which we have discussed, single list, right? Let me rename this one. It was single list. Let me rename this one stack. Stack single list, right? Let's see. Okay, stack single list. So the same, we have to modify this program. Same data structure we will use. Okay. Same type def and repeat here. We will not call the create function here. We will call this will be, we will delete this one. It's not required. We are not going to add any element at the end, right? Delete this one. It's not required. Display is required. We will display the stack. Get node is required. Allocate the memory. Now add at beginning. This is actually our push function. Push function. Got it? Add at post is not allowed here. Insert, you cannot insert any node in intermediate place, right? According to the rule of stack, you have to always maintain a sequence, isn't it? You cannot push an element in intermediate state, or you cannot delete, or you cannot remove any element from an intermediate state. Always last in, first out. You will have to remove always the element which has been inserted last. That needs to be removed. This is the principle of stack, last in, first out. So we have to maintain that principle, right? So that position is not valid here. Del node means pop function. So which will pop? Our pop function in linked list was you can delete any element from any position, right, according to the data provided by the users, isn't it? But here what we will do, we will have what element we will remove, which position in case of pop function, from where we always have to delete the node. Tell me, which node we will delete always? From what? Which position? In the linked list, we can delete the delete function, how we discussed, how we uh, explained that that will delete any node from any position. But here we cannot delete the nodes from any position. From a particular position, we have to always delete the node. So what is that particular position? Could you answer? Hello? Could you hear me? Hello?
Yes, sir.
So which particular position I have to delete the node always? Pop from the stack. Which element we delete? Last in, first out. The element which has been inserted last will be deleted first, isn't it? Hello?
Yes, sir.
Hello?
Yes, sir.
Responding.
Yes, sir.
You are not responding. Suchona, are you there? Suchona Das? Suchona Das?
Yes, sir. Yes, sir.
So do you hear me? What question I asked? That in pop?
No, sir. Actually, আমার নেটওয়ার্ক খুব ইস্যু করছে। আমি ক্লিয়ারলি কিছু শুনতে পাচ্ছি না, স্যার।
এখন শুনতে পাচ্ছিস?
হ্যাঁ, স্যার, শুনতে পাচ্ছি।
হ্যাঁ। তো আমি যে কোশ্চেনটা করেছিলাম, that While deleting the node from the stack, we always delete the node which we insert last in first out. So if we implement it in single list, from which particular position I have to delete the node? You are not actually concentrating. Here I told you that while pushing, push function means we have to always add a node before the first node, right? Isn't it? 32 comes before the 25, 50 comes before the 32, 99 comes before the 50. Because, isn't it? So means conceptually it is actually getting placed on the top. You are actually changing the top. This actually you can consider as root node. So the same principle will follow while deleting the node. Always we will delete the top node, topmost element we will delete. In stack what happens? You attended the class of the stack using array. So what we did there? We always removed the topmost element. The top means our root element, root node. So we will always delete the first node, nothing else. What we did in the single list, we always here in single list, I had written a generic function. From any position, you will be able to delete the node. But here, this is not allowed. According to the principle, last in first out of the stack, we cannot delete the node from any position. We must remove the element which is at the top. Means we will remove the topmost element, then we will change the value of the top here. When we will delete, according to this picture, if you want to delete this one, this will be deleted first. Currently top is pointing this. After we delete, this will be our topmost element, isn't it? So top needs to be changed after we delete. So delete from the first node always. So that is what we have to do. Means this implementation of stack using linked list will be a filtered form of the coding which we uh, studied in case of single list, right? এটা একটু আরো শর্ট প্রোগ্রামটা হয়ে যাবে। সিঙ্গল লিস্টে যে বড় প্রোগ্রামটা আমরা করেছিলাম কমপ্লিটলি, ঠিক আছে, এটা একটু ফিল্টার হয়ে যাবে। এখানে দুটো ফাংশন থাকবে, একটা পুশ ফাংশন আর পপ ফাংশন আর ডিসপ্লে ফাংশন। পুশ ফাংশনটা কি হবে? ক্রিয়েট ফাংশন হবে না। পুশ ক্রিয়েট ফাংশনে আমরা অলওয়েজ লাস্ট এলিমেন্ট অ্যাড করেছিলাম। এখানে পুশ ফাংশন কি করব? অলওয়েজ আমরা অ্যাড বিগিনিং করব। মানে অ্যাড বিগিনিংটাই আমাদের এখানে পুশ ফাংশন। আর এখানে ডিলিট দ্য ফার্স্ট নোড উইল বি আওয়ার পপ ফাংশন। বোঝা গেল? তাহলে আরো একটা ফিল্টার হয়ে গেল, ঠিক আছে? তাহলে এভরিথিং উইল রিমেন সেম। How many nodes you want to create means how many nodes, how many elements you want to push to the লেখো, তাহলে আরো বেটার হবে। How many elements you wanna push onto the stack, onto the stack. ঠিক আছে? স্ক্রিনটা দেখা যাচ্ছে তো? রে
হ্যাঁ স্যার।
এখানে আমি ধরলাম যে কটা একটা কিছু দিল, তাহলে এখানে আমরা পুশ push will always push a node on the element and it will change the root. Means it is add at beginning actually. Add at beginning. Display থাকলো, এখান থেকে add at beginning টা আমরা হাটিয়ে দিলাম, ডিলিট করে দিলাম। ডিসপ্লে বারবার এখানে আর দরকার নেই, একবারই ঠিক আছে। এইখানে একটা প্রিন্ট এফ দিয়ে দিই, দেখতে ভালো লাগে। এক্স ডিসপ্লে করা গেল। মোর সাথে ডিসপ্লেটা So enter the position, এটাও আমরা মাঝখানে we cannot insert any position, any intermediate position. We cannot insert any node, any intermediate position. Push doesn't allow this one. Always we have to push on the top. Okay. So now this enter the delete node. It's not required. এখানে এটা দিলাম, মুছে দিলাম। আমরা এখানে একটা পপ করে দেব। আমরা এখানে নাম দেব পপ। Since the value of the root means first node will be changed, this will be changed. That's why we need to pass the address of root. Okay. Then display root, display the list, right? বাকি সব ঠিক আছে। এখানে push pop everything is fine. বোঝা গেল? তাহলে কোডটা কতটা ছোট হয়ে গেল। তাহলে ক্রিয়েট ফাংশনটা আমরা ডিলিট করে দেবো, নেবই না। ফাংশনটা যেমন আছে তেমনই থাকবে, অ্যাড অ্যাট বিগিনিং, আর কিছুই থাকবে না, আর কিছুই থাকবে না, খালি থাকবে ডেল নোট বা পপ ফাংশন। পরে ডিসকাস করছি, আগে পুশ ফাংশনটা দেখে অ্যাড অ্যাট বিগিনিং। Did you understand the add at beginning? I think it was very easy, right? So how many nodes? Let's say the number of nodes we are inserting that has to be supplied by the user. Okay, and we'll catch the value how many elements we will push on the stack. So that is the this is a push function. I have to change the name, push function. And if it temp is get node, let's say when there was no element, first no element on the stack. Okay, the element we will be pushing on the stack, that will be our topmost element, that will be only element or the topmost element, right? So at beginning same thing, same concept. Okay. Temp get node, so we'll create a node and we will store the base address of that node into temp, and data part means this data part, let's say this data part 25 or whatever the user supplies, that will be that we have to assign in data component of the node, right? And temp arrow next, temp arrow next is star r, right? But here I have to change this one, temp arrow next is not star r, temp arrow next will be what, if had it been the first element, then this will be what, this will be actually the, this will be null. Okay, so temp arrow next is null and star r is 10. But here I have to do one thing. Temp arrow next is not now. Temp arrow next is star. Star. I have to like one thing here. If not star, if not star means when there was no node in the list, right? If not star, then temp arrow next is null. else, temp arrow. Next is star R and star R reflected. Let me first execute the code, then I will explain what I did. Okay, let me turn the deactivate the pop function currently, then we will activate it later on. Okay, push function, pop function. Push function load, display load, get node load. Okay, now let's save it and let's check. MAFA, no error. Now run the code. Run. Okay, let me turn off this avast antivirus. Run. Execute run. How many nodes? Let's say 5 nodes. 10, 20, 30, 40, 50. You see, the element which we pushed last was at the top. Okay. And the element which we pushed first, here it is in the last, right, in the stack. Got it? Are you getting? Could you see the output?
Yes, sir.
Hello?
Yes,
Hello?
sir.
Yes, sir.
Could you see the difference? Means this is the way we have to. Now I think it is better to display it vertically. It will look good. We can do that one also. If we display it, just change the display function a bit. Display function, you can do it after this printf control X. You just push this here. Let's write this control data arrow next. So it will look good. File, save, execute, compile and run. Let's say 5 element or 4 element and 20, 30, it 40, 10 it was inserted first, so it is coming at the last position, then 20, then 30, then 40. So now this is our root node 40. 40 is at the top of the stack. Got it? Which we inserted last. So push function is completed. Now when we will delete one, so definitely we have to delete, we have to remove the 40, then 30, then 20, then 10. This sequence means we always will keep on deleting the element from the first position, means we have to delete the root element, okay, or topmost element of the linked list, right? So delete this one, pop function. Now let's do it, pop function. So এখানেও কোডটা অনেক ইজি হয়ে যাবে, আমি এত কিছু টেক করব না, কারণ আমাদের কোডটা ছিল জেনারেল। এখানে আমি জাস্ট খালি যে ফাংশনটা আমি অনলি উই উইল ডিলিট দ্য ফার্স্ট করতে হবে, তাহলে আমি এত কিছু করবোই না, পুরোটাই বসে থাকবো। জয় দিলাম, তাহলে এখানে জাস্ট খালি করবো star r is star R arrow next. তার আগে একটা কাজ করবো, I will store it, the element which will remove now, we will store it in temp and temp so that we can make it free using free function physically from the memory. So temp is star R. Temp is star R. Okay. And star R is star R. Arrow next. Got it? Then printf. If I want to display, if I want the content of the node which is deleted to be displayed on the video, right? Then I have to do one thing. This is this double quotation slash n deleted element is this. So it is integer, so %d. To write temp. Now the deleted element is stored in the temp, isn't it? Temp is star r means the root node. First we are storing, what we are doing, first we are storing the root node in another variable, temporary variable. Then we are actually changing the root, isn't it? So changing the root means top means our star r, so star r is star r arrow next. Got it? So temp arrow dot data. Hello. Now I will the free function, make it physically free from the memory. Free. Okay. This is all about the Prof function. Okay. So this is not required. Brave and T is not required. Only temp. T, this statement is also not required. Fine. Save, execute, compile, execute, run. Say how many elements? Say 6 elements. 100, 200, 300, 400, 200, 600. 600, 500, 400, 300, 200, 100. Okay. But nothing is deleted because I didn't call it. No, I have just written the function. So I have to call this one. Prof function is, I think, is deactivated. So activate it. You can only remove the topmost element. So according to our previous data, the 600 was topmost element, so that will be deleted. Okay, so let's run it again. It's a good compiler. Run. Let's say 600, 200, 300, 400, 500, 600. Okay. First, it has been displayed the status of the stack 600, 500, 400. You can see the output. The screen is clear. Output screen is clear to you.
Yes, sir.
600, 500, 400, 300, 200, 1. Now I popped one element, delete element 600. So now it is displaying from the 500. If I again delete another element, let's say I again delete, I will delete again. I will delete. So I'll call the function, pop function again, control C. So I will just copy this one, Control C, and I can write one, Control V. Right. I do it again, Control V. So three elements will be deleted. First 600 will be deleted, then 500, then 400. So the stack will start displaying from the 300. Okay, let's run it and check. Execute, compile, and run. So let's give me the same data. Let's apply the same data. It's 600, 200, 300, 400, 500. Initially it was 600, started from the 600. After we did the first element, topmost element 600, it will start displaying from 500. After we did the 500, it will start displaying from the 400. After we delete the 400, it will start displaying from 300. Only three elements are left. Now I will give you one assignment. You will just watch my video again and again. It will be an assignment that if all the elements are deleted, right? Let's say after we delete the 100 also, this last element also, I should again, if someone try to delete an element, so it will display that no element is there or stack is empty. Means empty stack, that display, that message you want to have. Got it? After we delete all the elements, again if I want to delete, then definitely a message should be printed that no element present in the stack. So you are supposed to modify the program a bit and write the code for displaying that message. Got it? Hello?
Yes, sir.
Got it? Have you got my question?
Yes, sir.
Means this one, if I do this, let's say let me execute the program again. Run. Let's say three elements. Okay. I'm pushing the three elements. Then I have called the Prof function 3 times. Means all the elements will be removed. Okay. And then again, if I want to Control C, if I want to delete Prof function, it will be invalid. Means I should get an message that no element in the no element in the list stack, right? I didn't do it. So means this one, if I execute the program, say if I execute the program, compile and run, let's say I am inserting three elements and I have called the pop function 4 times. 100, 100, 300. Deleted, 300 deleted, 200 deleted, 100 deleted, then nothing is displayed. If I again call up a function, control C, control V, control V, number of times you put, okay, but nothing changed, no change will be there. But I should get a message, isn't it? Compile and run. That's every time again. 300, 200, 300. Nothing is coming, and you can see that at for a for a few seconds the program got paused. Could you notice this one? Did you notice this one? Means it is checking whether the element is there or not, but it is not finding an element, just it is terminating the program, right? So here, after you delete this, the last element, I should get a message here that no element present in the stack or stack is empty. That you have to do. You just will modify the program, and I will give the assignment. Got it? Hello.
Yes, sir.
Understood?
স্যার বাট স্যার আপনার ওই যেই প্রোগ্রামটা দিলেন ওই প্রোগ্রামটা দিয়েই তো করতে হয়।
ও ওটাতেই মডিফাই করে দিবি, আমি দিয়ে দেবো।
ওই
ঠিক
তাহলে
আছে,
তো ওই প্রোগ্রামটা স্যার একবার
হ্যাঁ
ভালো
আমি
করে
দিয়ে দেবো,
দেখে
আমি তো দিয়ে দেবো, আমি তো পিডিএফ এ দিয়ে দেবো, তোরা আবার ওই করে দিবি, নিজের মতো কপি করে ওটাকে পেস্ট করে নিবি, ঠিক আছে,
হুম,
ডেপসিতে, তারপর ওখানে মডিফাই করে আমাকে জমা দিয়ে দিবি, ঠিক আছে।
হুম,
দেখবি যেন এটা বলে যে ঠিক আছে, নো এলিমেন্ট, দেয়ার ইজ নো এলিমেন্ট, ভেরি ইজি, একটা দুটো স্টেটমেন্ট লিখতে হবে। আমি জাস্ট চাচ্ছি তোরা ওটা ভালো করে স্টাডি কর, এটা যদি করতে যদি একটা কাজ দিই তবেই স্টাডি করবি, না হলে তোরা স্টাডি করবি না, আমিও জানি, বুঝতে পারছিস। কিছু বলতে গেলে যে একটা গোড়া কোশ্চেন, স্যার এটা তো আমাদের ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং এর নয়, কম্পিউটারের ক্লাস, কম্পিউটারের সাহায্যে কিছু হয় না। কম্পিউটারের যেমন ইলেকট্রিক্যালের কি বলবি কি এটা তো আমাদের একটা মেশিন, ইলেকট্রিক্যাল মেশিন, তুই কি বলবি ইলেকট্রিক্যাল সাবজেক্ট, ইলেকট্রিক্যালের অনেকগুলো সাবজেক্ট আছে, 30 থেকে 35 সাবজেক্ট আছে, isn't it? Total second year, third year, fourth year, if I discuss the first year, the general science, the second year, third year, fourth year, how many subjects you have? So many subjects, না? সেরকম কম্পিউটার সায়েন্সে প্রচুর সাবজেক্ট আছে, যেটা তোদের আইটি ইন্ডাস্ট্রিতে চাকরি পাওয়ার জন্য সাবজেক্ট which are 3 to 4 subjects, means the core subjects you need to study and you will get a chance in any IT sector, right? So that data structure, a language C, DBMS আর বড় জোর একটা এই দুটোই মেন, DBMS ডেটা স্ট্রাকচার আর একটা ল্যাঙ্গুয়েজ সি ছাড়াও একটা ল্যাঙ্গুয়েজ যদি শিখতে পারিস ভালো। আর লিটল বিট ফ্রম তো দ্য ডিবিএমএস তো আছে আই থিঙ্ক, না ডিবিএমএস ইজ দেয়ার ইন ইউর ফোর্থ ইয়ার, না? Would you ever have you ever seen your complete syllabus up to fourth year? Fourth year of the complete syllabus কেউ দেখেছিস, একবারও চোখ বুলিয়েছিস কিরে?
স্যার দেখেছিলাম।
ডিবিএমএস দেখবি আছে তোদের ইলেকট্রিক্যাল, আছে তো?
জানি স্যার, ঠিক আমি
বা
অত
কিছু একটা
জানি
আছে ইলেকট্রিক্যাল ডিবিএমএস, ডিবিএমএস এর জন্য ইম্পর্টেন্ট। তাহলে ডেটাবেস ম্যানেজমেন্ট সিস্টেম, ডেটা স্ট্রাকচার, সি, এই তিনটেই মেন। আর যদি একটা জাভা টাভা কোনো একটা ল্যাঙ্গুয়েজ শেখা যায় ভালো, তাহলে ওটা ডিপেন্ড করে, অতটা ম্যাটার করে, মেনলি এখান থেকেই কোশ্চেন পাবে আইটি কোম্পানিতে চাকরি করার জন্য। আর তুই যারা জানিস যে আগামী 8 to 10 years the market, the domain which will get the boom, that is the computer science and IT market. ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং মার্কেট জেনারেলি একটা অ্যাভারেজ থাকে, স্যাচুরেটেড, কারণ এখানে তো কোর জায়গাতে চাকরি করবে কি, মানে সবাই তো ওখানে অলরেডি স্যাচুরেটেড, না? ম্যানুফ্যাকচারিং তো কম হচ্ছে, ম্যানুফ্যাকচারিং কোম্পানি যেগুলো নতুন নতুন করে কম আসছে তো, না নতুন করে লঞ্চ কম করছে, তাহলে সেখানে এটাই হচ্ছে ব্যাপার। ওকে চল, লেটস কনক্লুড দ্য সেশন, ওকে, বাই।